All right, so let's look at this one. Acetic acid, and I give you the formula, HC2H3O2, because we haven't got to naming acids yet. If we got to naming acids, you would have to know how to write that. So acetic acid reacts with the metal aluminum to make aqueous aluminum acetate, and that was nice, I gave you that formula, but technically you should know how to write aluminum acetate, and gaseous hydrogen. And I give you some hints. Acids are always aqueous and metals are solid except for mercury. So the first thing we want to do is we want to write it out in words. What's reacting with what? So it says acetic acid reacts with the metal aluminum. So we say acetic acid reacts with aluminum. Okay, so we know that. So acetic acid reacts with aluminum to make. So now I'm going to produce something, so those are my products. It's going to make aluminum acetate. And gaseous hydrogen. So first I kind of want to write it out in words so I can see what I'm working with. Now I want to put the formulas and their states. So acetic acid they gave me. And state. This is acetic acid, and I said that acids are always aqueous. So if it's aqueous, that is a Q. Next is aluminum. Aluminum is just the element, so just Al. And it says that it is metal aluminum, and I remind you that metals are all solids except for mercury. So since it's a metal, it's going to be a solid. Goes to aluminum acetate, which I gave you the formula, so all you have to do is copy that down. And it says that it was aqueous aluminum acetate. So that tells me the state of my aluminum acetate. Plus hydrogen. So hydrogen, is that just going to be H, or is that going to be H2? So that's another one of the diatomics. It's H2, and it says it's gaseous. So I'm kind of running a little bit out of room, but it's gaseous. Okay? So we write it all down. This is the hardest part, and if you get this wrong, you're going to get the rest wrong, because you have to know what the formulas are to be able to say how many of each element you have. So if for some reason your balanced equation isn't kind of coming out and you're not getting it to work, make sure you wrote the formulas down correctly, because if you write these down, the balanced equation it won't balance sometimes. Okay? All right, what elements do I have? I have hydrogen, carbon, oxygen, and aluminum. On the other side, hydrogen, carbon, oxygen, and aluminum. It's the exact same. All right, how many hydrogens? So I need to notice that I have hydrogens here and here. This whole thing, if you just add this up, this is 3 and 1, so I have 4 here. So just write a big 4 because it's coming from the same thing. This whole thing has 4. It's not coming from 2 different ones. Carbon is 2. Oxygen is 2. Aluminum is 1. Okay. Hydrogen, I have 3 times 3 is 9. But I also have the 2 here. So there's 9 and 2 makes it 11. Carbon, I have 2, but 2 times 3 is 6. Oxygen is 2, but 2 times 3 is 6. And the aluminum is just 1 because it's not in the parentheses. This just goes to everything in the parentheses. So this is just a 1, so I only have 1 aluminum. All right, so now I got to figure out what I'm going to start with. Where do I want to begin? And so we said we want to do everything besides hydrogen, carbon, and oxygen. So the first thing would be aluminum. Well, aluminum's fine. So we're like, okay, leave it alone. We're good. Next, we want to do either hydrogen, carbon, or oxygen. But we don't want to do anything by itself. Hydrogen is by itself, so we want to ignore hydrogen and do it later. So you can either do the carbon or the oxygen first. It really doesn't matter. You pick. I'm just going to do the carbon because it's above the oxygen. So I've got 2 here, I have 6 here. which side do I need to make bigger? I need to make this side bigger. So that means there's going to be a number on this side. What number can I put here that multiplies by 2 to give me 6? That would be a 3. Because 3 times 2 would give me 6. 3 times 2 gives me 6. So my carbons are good. But now I've screwed up the hydrogens. The hydrogens were 4. But now I have a 3. So 3 times 4 gives me 12. Also messed up the oxygens. It was 2, but now 2 times 3 gives me 6. So now I have the carbons. We said the next thing we were going to do is oxygen. But wait, my oxygens are good now. So sometimes that happens. Sometimes when I fix one guy, I make the other one good to go too. So you can kind of kill 2 birds with 1 stone. So aluminum's good, oxygen's good, carbon's good, all I have left is hydrogen. So I've got 12 here, I have 11 here. So that means that this side needs to go up, but I have 2 choices. So now we want to think about it. If I have 2 choices, I could put a number here, or I could put a number here. If I put a number here, then I'm screwing up the aluminum, the carbon, and the oxygen, which we already said was good. So I don't want to put it here, because I only want to change the hydrogen. So that's why I want to put it here. Because if I put it here, it only changes the hydrogen. All right, so let's think. How many do I need? I need 12. Your thought might be, okay, what number do I put here to multiply by 2 to get 12? And you might think 6. But if I put 6 here, that changes this number to 6, which would give me 15. Okay? I don't want 15. I want this whole thing to be 12. So the way we want to think about this is I want this whole thing to be 12. I have 9 from the first one. So if I want this whole side to be 12, I have 9 from this. So how many more do I need to get to 12? I need this to be 3. I need that one to be 3 so that I can get to 12. So how do I get this to be 3? What can I multiply by 2 to get 3? A fraction. Okay? This is kind of the hardest part, is when you have 2 of them, you have to kind of break it down. So if I need this to be 3 and I've got a 2, I need a fraction, so what number goes on top? It's what you need, which is 3, not 12. What goes on bottom is the subscript, which is the 2, so 3 halves. Because 3 halves times 2 is 3, and then 3 times 3 is 9, 9 plus 3 is 12, and that's how many I needed. But am I done? I have a fraction, so what do we have to do? To get rid of my fraction, I have to multiply everything by the denominator of the fraction. So the denominator of the fraction was a 2. So I need to multiply everything by a 2. So 2 times 3 gives me 6. 6 acetic acids. 2 times 1 gives me 2 aluminums. 2 times 1 gives me 2 aluminum acetates. And you can just always write stuff on the bottom. And 2 times 3 halves gives me 3 hydrogens. If you run out of room on your paper, you always want to write it just below on the same side of the arrow. So don't say plus and then start a new line. Make sure that if you have too much, you kind of add plus and then you drop it. Like if there was a plus here, you would drop it and put it on this side so that it's actually on the correct sides of the arrow. All right, let's do our check. So hydrogen, that's 3 and 1 is 4. 6 times 4 is 24. This is 3 times 3 is 9, times 2 is 18. 3 times 2 is 6, so 18 and 6 is 24. And you can write this out, put it in your calculator if you don't want to do it in your head. 2 carbons, 2 times 6 is 12. Here's 2 carbons, 2 times 3 gives you 6, but there's 2 of them, gives you 12. Oxygen, 2 times 6 is 12. 2 times 3 is 6, times 2 is 12. 2 aluminums, 2 aluminums. So we are good there. So if you can do this, this is as hard as it gets. Okay, so this is as hard as it gets because you were given the names, you have to write the formulas, you had to figure out the states, you had to balance it, being with a fraction and with the funky having two things and trying to figure out what the fraction would be, and then checking it, you know, having stuff in parentheses and all that. So if you can do this one, you're good to go, okay? So now we're gonna switch gears, and now that I have a balanced reaction, now I wanna actually say, well, what if I start with some amount of this? How much of that can I actually make? So now we're actually gonna start doing some math that's very applicable for doing reactions.